CEO of JIJ here. I'd like to talk about the JijZept, integrated quantum optimization platform, and its potential. And optimization quantum circuit transpiler, which we announced, I'd like to talk about that. So if you're interested in optimization calculation, and if you're interested in R&D using quantum calculation, I think this presentation will be interesting to either of them, so please listen. First, I'd like to talk about us, JIJ. Why JIJ to begin with? So statistical dynamics is my field, and there's this Ising model, and there's this binding constant, and we use the JIJ alphabet for that. So why did we use the large J? Why the physicists choose that, I don't know, but this comes from there. So it's for the physicists, it's clear that it's a startup established by physicists. And so we were founded end of 2018, and so optimization calculation is what we did. And I'd like to talk about our products and services. I'd like to talk about specifically JijZept, and finally our open source project. Well, first, JIJ. The overview of our products and services. So two major things. One is the JijZept, integrated quantum optimization platform. And so of optimization with constraints. Starting from there, we have solvers and the quantum computer. So it's a transpiler technology to convert to that. And then we have the post-processing technology to conduct a statistical treatment. And then based on that, we have the our joint research and solution support. One-stop support for the use of this optimization quantum technology. So I don't have time to talk about the solution use case. I'd like to focus on the technology of JijZept. So Zept. So other than the cloud platform, we have various products. It's a JijZept series. So Zept series, open source, free software, and JijZept for fee cloud services. So there are those two major pillars: free software, JIJ modeling. It's a modeling tool for optimization. Then there's a transpiler, then transpiler for quantum. So there are those tools. The other part is JijZept, and so various functions provided in this cloud platform. And also this another point. What's different with other platformer is that we have hybrid algorithm tool to solve complex optimization or complex optimization problems. So JijZept quantum and Ising optimization platform. So I'd like to explain this. So this is the visual that's been blown up. Zept. So it's a modeling tool for optimization, and especially people here are involved in quantum, so optimization calculation, and you might think about the combination optimization, but optimization with constraints, higher abstraction. So without converting to Kubo, to do straightforward modeling. So that's the tool that we provide. And we have, by providing the transpiler, converting to Kubo can be done automatically. And also, we have the ordinary optimization solver, and then annealing machine or hardware for annealing. Well, we support the various types of such hardware. and then we can have statistical analysis or can be converted to a lower level format that's easier to use for the user. And so the simple to use modeling tool is where we start. And in terms of the interface, this is what we have. Python SDK is used, so it's intuitive. Some mathematical model variables are defined, and then that is made into the equations. And this is the traveling salesman. And so in the same time, salesman has to be in one place and has to go to all the places. So those are the two constraints that's written there. That's all you need to do. And you can have optimization calculation. So we have the technology to transpile that, and you send it to JijZept. Then, depending on the hardware you select, it's converted. D-Wave or Fujitsu Digital Annealer. So Kubo solver, if it's going to be used for that, then it is converted to that Kubo for that. And then if you're going to use a quantum circuit, and then it will be converted to that format. And then taking that output, you do post-processing, and then you can provide better optimization to the user. Big characteristic of this tool is, so the current Ising machine can handle big problems by using these annealing machine. There are some use cases, 10,000 to 100,000 to a million variables. Those use cases are handled. And at that scale, those parts other than optimization calculation become bottleneck, like data sourcing using cloud, or creating the problem with Kubo. That will be the dominant part of the calculation. And so Kubo generation speed compared with other open source, it's 5 times faster. And data, we have developed a compression algorithm. So when you use it in the cloud, it's 3 over 10,000 in best case. So a very high compression rate. So by using JijZept, the calculation bottleneck other than the optimization calculation can be resolved, and you can focus on the optimization computation. And we support multiple hardware. Last month, annealing, Fujitsu, NEC, Toshiba, D-Wave, Microsoft, we formed a partnership with them. Their hardware are all natively supported. When I say native support, that's quite important. For example, Fujitsu machine, or you can handle constraints very efficiently, so the user don't have to think about that. Based on the mathematical model written, we do a pattern match. With this constraint, then this kind of parameter should be put on, or it should be converted to Kubo. That's all automatically done. So if you go through JijZept, then you can bring out the most of the performance of the hardware. And if you don't know the hardware, you can make the most of that hardware performance. That's the transpiler technology that we have. And then quantum circuit platform are supported, and also MIP solver, CBC, Cplex, Groby, all of that are also supported. And JijZept lab, hybrid algorithm tool, is what I talk about. So the small part at the corner. So optimization calculation. Well, the difference with the conventional players is that the optimization calculation, whether it's annealing machine or quantum computer, we think that that will not be solved by that, not just now, but in the future. You need some kind of hybrid algorithm, because the current MIP solver, they don't solve with just one algorithm. And you do problem decomposition and put it into various algorithms, then you make it look like it's one solver. So optimization calculation, essentially, that's the only way to solve it. And so based on that assumption, we decompose problem. So we provide that external layer for that, like the Bender's decomposition, dancing wolf decomposition, very famous algorithms. But the quantum players don't know much about this. And by providing these as products, big complex problems can be handled by anyone. So that's the JijZept lab. So this is one example using Bender's decomposition. And you want to solve this. It's not discrete variables. Also, there's continuous variables as well. So it's theoretically decomposed, and then that is solved. And what's good about our decomposition algorithm is that if you use heuristics, the solution from the solver, is it the true global minimum? There's no way for us to know. But with our algorithm, at least that solution, we know how close it is to the true solution. And so we can talk about the distance to the true solution. So not only can we solve big problems, we have the option to provide information how close you get. So this is the interesting algorithm that we provide. So using that JijZept foundation, so far we've worked with Toho Gas, Toyota Tsusho, KDDI in various fields. We have explored use cases. As of now, energy sector, logistics, material science, these are the areas we're focusing on, establishing partners and exploring JijZept use cases. Now, final topic. So I talked about the JijZept. So as shown in the use case, it's usable not just for R&D, but in very large, complex problems actually in the field. You can do optimization calculation for that. Now, quantum computing technology for the real world, we are hoping it will be a good solution, but optimization and quantum computing algorithm, technically there's a big difference. And so optimization calculation knowledge can be brought into the quantum to promote that development, and we're developing a tool for that, and that's what I talk about now. And this is JJ modeling transpiler for quantum. So talk about them. JJ modeling. Well, this is to write a mathematical model. So you have this pip install. So you can install with that. And then there's a transpiler, various quantum circuits and others. So transpile to mathematical model. So I talked about JijZept. You're able to handle big data. So it's a free version that removes that capability to handle big data. And also there's the open source optimization experiment managed tool, MINT, management and insight tool. So that's in the slide. I haven't talked about it. So except for the MINT, I'd like to talk about JJ modeling and transpiler. So JJ modeling transpiler. So you have a mathematical optimization. So you do the JJ modeling. And then using the transpiler, you can use a Kubo, Cplex, Groby, or free CBC, and then quantum algorithm. You can convert to such things, and then you don't have to know the interface. Just learn JJ modeling, and then the transpiler technology can convert to each format. This is Q2B, so JJ transpiler for quantum is what I will focus on. So JJ modeling transpiler for quantum, what's interesting is, well, we need quantum algorithm for optimization, global or QAOA, I think you're familiar with that. But then there's also QRAO, random access encoding. So multiple quantum or multiple classical bit embedded in the quantum bit to do the optimization calculation. That kind of encoding is supported. Also, JJ modeling transpiler, we avoid black box for the researcher to make it easy to do research. So for various platforms, the circuits can be provided. How to solve that is left up to the user, and so user can customize this freely. And then, so there's seamless integration to Qiskit. So Qiskit primitive is used for Qiskit runtime to do so we have to go back between classical and quantums. By using that Qiskit runtime, you can have a more efficient optimization algorithm. And the supported platform is being expanded. Qiskit and Curie pods. Someone talked about this. Uniform platform being developed by Qiskit, and so it's not just Qiskit. Very fast circuit simulator like a QLAX, Circ, Bracket. More quantum platforms are being supported. This part, so there are many tools that support QAOA, not so many that support QRAO. So QAOA, this is one classical bit is embedded into one qubit, then you do the optimization. So you can only handle small problems with the current device. QRAO, various encoding methods. If it's 3, 2, 1, then 3 classical bits can be encoded here, and so it could be represented by 1 qubit. And in the ideal situation, if you have 10 quantum bit, then you can encode a 30-bit problem, so 3 times. So bigger problem can be solved, and by optimization algorithm using this new encoding. Well, encoding itself is a hassle, so you can leave it to this transpiler, and you can describe. And you can focus on solving. You can focus on the algorithm because the conversion part will be handled by this. And this is the modeling in one screen. So you do the JJ modeling, and then it will be transpiled to each modeler. Then Qiskit QAOA, QRAO, and then using Qiskit primitive, optimization is done, and then the solution comes out using metadata. So it's like 4x4 if it's Qiskit, and so you get a 4x4 answer, not the quantum bit, but actually as a solution, easy to interpret for humans. So to review, JijZept series, there's JJ modeling transpiler and transpiler for quantum. So those are open source, and then there's the JijZept. More when you want to solve more realistic problem, large problem, it's a cloud service. So finally, so from JIJ, this is our message to you. So Zept is integrated quantum and Ising optimization platform. If you're interested, please use this QR code to visit our link. Please look at the Zept documentation. Also, using Zept, we've already done many use cases. So if you want to know about the use cases, I'll be here until the end, so please talk to me. JJ modeling transpiler quantum. If you're interested, you can do pip install, and with GitHub, it's open source, and the repository link can be reached from the QR code. So from here, please go to GitHub and access. So I talked about Zept and JJ Mulling transpiler, and we're solving various actual problems and doing quantum research as well. Multiple JIJ members are here, so if there are any parts you're interested, please talk to us. With that, I conclude. Thank you.